चलिए हम लोग आज पढ़ेंगे चैप्टर नंबर 4 और इसमें है यूनिट ऑपरेशंस पार्ट 1 साइज रिडक्शन एंड साइज सेपरेशन पॉइंट टू बी कवर्ड इन दिस टॉपिक। फर्स्ट पॉइंट में पढ़ेंगे हम लोग इंट्रोडक्शन, फिर 2 में पढ़ेंगे साइज रिडक्शन और फिर हैमर मिल क्या है, बॉल मिल, इन सब के बारे में जानेंगे। फिर साइज सेपरेशन कैसे होगा, क्लासिफिकेशन ऑफ पाउडर अकॉर्डिंग टू आईपी, साइक्लोन सेपरेटर और सीव्स और स्टैंडर्ड्स ऑफ सीव्स। ये देखिए, शुरू करते हैं। यूनिट ऑपरेशंस, इंट्रोडक्शन सबसे पहले होगा। इसमें देखिए, Pharmaceutical unit operation involves various operations such as size reduction, size separation, mixing, drying, filtration, extraction. First, next point, it deals with the conversion of compound into the final products. Point third, it is based upon physical, chemical, and engineering principles. Size reduction. Size reduction is a process of reducing large solid unit masses, vegetable or chemical substance, into small unit masses, coarse particles or fine particles। ये दिखाए गए हैं कोर्स पार्टिकल और ये फाइन। Size reduction process is also known as domination or pulverization or comminution, derived from Latin word minor, means less. Objectives of size reduction. Size reduction increases the surface area and hence increases the rate of drying of a material. It allows the rapid penetration of solvent during extraction. To get a uniform powder, size reduction helps in uniform mixing of drugs that is required for preparation of formulation. It is necessary to increase the rate of absorption of a drug. It increases the therapeutic effectiveness of drug. It is necessary to improve the stability of certain dosage forms. It helps in the process of separation of solids from liquids. It improves the appearance of the mixture. Theories of size reduction. Griffith theory. The Griffith theory states that a crack will propagate when the reduction in potential energy that occurs due to crack growth is greater than or equal to the increase in surface energy due to the creation of new free surfaces. Rettinger's theory states that energy required in a size reduction process is proportional to the new surface area produced. Bond theory states that work required to form particles from a very large field is proportional to the square root of the surface to volume ratio of product. Kick's theory. Kick's theory states that the amount of energy required to crush a given quantity of material to a specified fraction of its original size is the same regardless of the original size factor affecting size reduction. Hardness. Hardness is the surface property of substance. It is easy to break the soft material than hard material, which is determined a device known as Ohm's Mohs scale range 1 to 10. Toughness. The crude drugs having fibrous nature are tough. The tough material may create more difficulty in size reduction process. Abrasiveness. As material causes wear and tear, special equipments and required for their size reduction. Stickness. Stickness causes lots of difficulty in size reduction as the sticky material may adhere to the grinding machine altering the process. Moisture content. Moisture below 5% is suitable for dry grinding and above 50% are suitable for wet grinding. Bulk density. The output of the size reduction of material in a machine depends upon the bulk density of the substance. Mechanism of size reduction. मैकेनिज्म ऑफ साइज रिडक्शन में सबसे पहले आता है कटिंग. द मटेरियल इज कट बाय मीन्स ऑफ अ शार्प ब्लेड विथ अ defined shape can be processed further. It is used full for communication of fibers or waxy solid. Cutter mill. Compression. On this mode, the material is crushed between roller by the application of pressure. Compressive force are used for the coarse crushing of hard material. Attrition. This process involves breaking down the material by rubbing action between two surface phenomena. It is generally necessary for fine grinding. Fluid energy mill. Impact. When moving particle strikes again a stationary phase. In the same way, particles moving the high speed collide each other and produce smaller particle. Fluid energy mill and hammer mill. Equipment used in size reduction. There are various types of equipments used in size reduction as given in table 4.3. General characteristics of various types of mill. Name of the mill, action, product size, usage or material not used. Cutter mill, cutting 20 to 80 mesh. Uses fibrous, crude, animal and variable material, vegetable drug, variable material. Roller mill, compression 20 to 200 mesh. Soft material, abrasive material. Hammer mill, impact 4 to 325 mesh. Almost all drugs, abrasive material. Design, disintegrate और ये बॉल मिल. इम्पैक्ट में 20 to 80 mesh. Almost all drugs it including hard drug. Soft and sticky material. Ball mill में attrition and impact 20 to 200 mesh. Brittle drugs. soft material, fluid energy mill, attrition and impact. 1 to 30 micrometer, moderately hard and variable material, soft and sticky material. Hammer mill. A hammer mill is an impact mill commonly used in pharmaceutical manufacturing for reducing particle size for a variety of drugs. Principle. Hammer mill is based on the principle of impact between hammer and powder material that is more or less stationary. Construction. Hammer mill consists of a metal casing. It has four or more hammers are attached to enclosed central shaft. When the shaft is rotated with the help of motor, the hammer swing out to a radial position. It is then collected in a suitable receiver when the desired degree of size reduction is reached. On the side of the casing, there is a feed hopper, milling chamber, shaft, hammer, screen, product, receiver और hopper. Hammer mill दिखाई गई है ये. You can see it. Working. The hopper is used to place the feed material. The material from the hopper flows vertically and then horizontally. The hammer are continuous motion and rotating at a high speed of 800 to 8,000 to 15,000 revolution per minute. When the feed material strikes with the rotary hammer, the material breaks down into smaller pieces. Then these particles pass through the screen. High speed, low speed mesh size of chip, thin screen, thick screen. Influence of the speed on particle size. Influence of thickness of the screen of particle size. Advantage. Easy to set up, dismantle and clean up. Rapid in action. Capable of grinding many different types. Capable of grinding many different type of material. Hammer mill occupies small space. एडवांटेज हमारे फोर हैं लगभग. इजी टू सेटअप, डिसमेंटल एंड क्लीन अप, रैपिड इन एक्शन, capable of grinding many different type of materials. Hammer mill occupies small space. Or disadvantage, heat buildup during milling is more. Hammer mills cannot be employed to mill sticky fibers and hard materials. The screens may get clogged. Used Usage जो है, hammer mill is used to mill dry material, wet filter presses, cakes, ointments, slurries, etc. It is used to brittle material that is waste fractured by impact from blunt hammer. It is used to fibers material that we waste reduced in size by cutting edges. Variants: stock tornado mill, fit Fitzgerald कम्यूटिंग मशीन, जिसको शॉर्ट में कहते हैं फिट्ज मिल. माइक्रोपल्वराइजर, हैमर क्रशर, बॉल मिल. Ball mill is also known as tumbling mill or pebble mill. Principle: its work on the principle of impact and attrition between the rapidly moving ball and the powder material, both enclosed in hollow cylinder. Cascading, contracting, centrifuging. Principle of ball mill. Cascading. At low speed, the ball tumbles roll and jump down on the material. Catracting. At increased speeds, the ball reaches the top of the mill and falls on the material. Impact predominates in the process. C. Centrifuging. At high speed, circular motion of ball occurs with no fall. Construction. Ball mill consists of a hollow metal cylinder mounted on shaft and rotating about its horizontal axis. The cylinder can be made of metal, porcelain, or rubber. Inside the cylinder, balls or pebbles are placed. The balls occupy between 30 and 50% of volume of the cylinder. The diameter of the balls depend on the size of the feed and the diameter of the cylinder. The diameter of the walls varies according to size of the feed and diameter of the mill. The balls can be made of metal, porcelain, or stainless steel. Metal cylinder, lid, steel balls, feed material, construction of ball mill. Working. The drug is put into the cylinder of the mill and the rotated. The speed of rotation is very important. The maximum size reduction is affected by impact of the particle between the balls as given. The steps involved in the working process of ball mill are initial stage. The powder particle are flattened by the compressive force due to the collision of the ball's micro forging leads to changes in the shapes of individual particle or cluster of particle being impacted repeatedly by the milling balls with high kinetic energy. Intermediate stage. Significant change occur the comparison with those in the initial stage. Cold welding is now significant. The intimate mixture of the powder constituent decreases the diffusion distance to the micrometer range. Final stage. In this considerable refinement and reduction in particle size is evident. Completion stage. At this stage, the lamellae are no longer resolve, resolve, resolvable, resolvable by optical microscopy. Real alloy with composition similar to the starting constituent is thus formed. Advantage. It is capable of grinding a wide variety of material. It can be used in a completely enclosed form. It can produce very fine powders. It can be used to continuous operations. Very suitable for wet or dry process. Disadvantage. Very noisy machine. Slow process. Wear occurs from the walls and casing result in contamination of the product. Soft, soft tacky fibers material can be milled ball mill. Ball mill is used for production of ophthalmic and peripheral product. The ball mill having less capacity is used for wet grinding such as in suspension and that of having High capacity is used for milling ores. It is used for milling dyes, pigments, and insecticides at low speed. Variants: Harding mill, continuous ball mills, vibrating balls mills. Size separation. Size separation is unit operation that involves the separation of a mixture of various size particles into different portions by means of screening surface. This technique is based on physical difference BYW. The particles such as size, shape, and density. It is also known as sieving, sifting, and screening. Objective of size separation. The objective of size separation are the to determine particle for the production of tablets and capsules, to improve mixing of powders, to improve the solubility and stability of particle during production, to optimize feed rate, agitation, screening during production, to improve quality control of raw material. Classification of powder according to IP. The IP specifies five grades of powder as given in table 4.4. Coarse powder. A powder is called coarse powder in which all particles of which pass through a sieve with normal mesh apparatus of 1.70 mm, number 10 sieves, and not more than 40.0% through a sieve with nominal mesh operator to 355 micrometer, number 24 sieves. Moderately coarse powder. A powder is called moderately coarse powder in which all the particle of which pass through a sieve with nominal mesh of apparatus of 710 micrometer, number 22 sieves, and not more than 40.0% through a sieve with nominal mesh apparatus of 22 to 50 micrometer, number 60 sieve. Moderately fine powder. A powder is called moderately fine powder in which all the particle of which pass through a sieve with nominal mesh operator of 355 micrometer, number 44 sieves, and not more than 40.0% through a sieve with nominal mesh operator of 180 micrometer, number 85 sieves. Fine powder. A powder is called fine powder in which all the particles of which pass through a sieve with nominal mesh operator of 180 micrometer, number 80, sieve number जो है 85. Very fine powder. A powder is called very fine powder in which all the particles of which pass through a sieve with nominal mesh operator of 125 micrometer. Sieve number 120. Classification of powders according to IP. ये देखिए grade powders, sieve number, nominal mesh operator, sieve through which 40% particle or nominal mesh operator size. Coarse powder, moderately coarse powder, sieve number 10 से 22. ये nominal mesh operator size 1.7 mm, 710 micrometer, or sieve through in which 40% particles pass 44, 63, 55 micrometer to 50 micrometer. Moderately fine powder 44, 355, 85, 180, और fine powder 85, 180, same no, और 5 नंबर very fine powder जो होगा 120 particles must pass, सीज 125 माइक्रोमीटर। और इसके आगे का वीडियो बनाएंगे अगले में। धन्यवाद।